So good afternoon, Mandal. So now I would like to say something basic elements, Ohm'S and KVL and KCL. So before going to topic, so in the olden days, this subject is nothing but BEE. So it is nothing but basic electrical engineering. So this BEE is now going to for civil and mechanical branches, basic electrical and electronics engineering. So now I'd like to say something about basic elements of electrical circuits. So there are three main circuits elements. So the three main circuits elements is nothing but resistor, inductor, and capacitor. So the resistor is nothing but it opposes the flow of charge. So which opposes the flow of charge. So the resistance units is ohms, and the relation of that v is equal to, according to Ohm's law, v is equal to IR, and again v is equal to IR, and I is equal to v by R. So according to Ohm's law, so basic Ohm's law statement is nothing but the current flowing through a circuit is directly proportional to applied voltage at a particular temperature. So that is I directly proportional to V. So current is directly proportional to V at a particular temperature. So I directly proportional to V into 1 by R. So I is equal to V by R. Next, inductor. So inductor, it can stores the energy in the form of magnetic field and the units is Henry. So it opposes change in current also. Next, similarly capacitor. So it stores the energy in the form of electric field. So here the small difference between inductor and capacitor. So inductor and capacitor, it can stores the energy, but in the form of magnetic field is nothing but inductor. In the form of electric field is nothing but capacitor. So the unit of capacitor is farad. So next, voltage source, generator, battery. So these are all of one of the circuit element. So voltage source, it supplies the electrical energy, and the types of voltage sources: independent sources and dependent sources. So the independent sources is DC or either AC sources. So dependent sources, it is totally controlled sources. So next, last one, current source. So current source is also one of the basic circuit element. So it supplies only constant current. So it case in the independent or dependent. So next, I'm taking again here Ohm's law. Ohm's law. So the current through a conductor is directly proportional to applied voltage at a particular temperature. So simply it is called V is equal to IR. So next, Kirchhoff's laws. So here there are two laws: Kirchhoff's voltage law and Kirchhoff's current law. So in Kirchhoff's voltage law, we can finding that voltage, and similarly current law we are finding current. Okay, see here. So KVL. So KVL, it states that the sum of all voltages around the closed loop is equal to 0. So it can be written as sigma voltage sources is equal to sigma voltage drops. So are equivalent to sigma V equal to 0. So the simply it is called as the algebraic sum of voltage sources is equal to in the loop is equal to 0. Next, KCL. So KCL, it states that the total current entering in a junction in an electrical circuit is equal to total current leaving at the junction. So this is based on the principle of conservation of charge. So mathematically it expressed as sigma entering current entering current is equal to leaving currents. So it can be written as sigma I is equal to 0. So next, let us take the here properties of conductor. So conductor allows the current power. So under static conditions, no charge and no electric field can exist at any point within the conducting material. So the charge can exist the surface of the conductor, giving that rise to surface charge density. So within the conductor, the charge density is always 0. Next, the charge distribution of the surface, it depends on that shape of the surface. So the conductivity of an ideal conductor is infinite, and the conductor surface is equipotential surface. So these are all of the conductors of properties. So in the bit before, properties of conductor is over. The next, classification of elements. So in the here DC circuits, the elements are typically classified 3 basic components. So that is nothing but a resistor, inductor, capacitor. So these elements respond of the DC currents in different ways, and each has unique characteristics in terms of how they stores the energy, dissipates energy. So here's how each is classified and behaves. So the resistor, the symbol is so this is nothing but a resistor symbol. So the resistor in units is Ohms. So the function of the resistors resist the flow of electric current and convert electrical energy into heat. So according to Ohm's law, V is equal to I into R. So then V is equal to I into R. So next, inductor. Inductor, it can stores the energy in the form of magnetic field. Next, capacitor. Capacitor stores the energy in the form of electric field. So the total differences of that basic circuit elements, that is RLC, resistor, inductor, capacitor. So resistor, the behavior of in DC circuit and energy storage. So in the resistor, the current is directly proportional to applied voltage. So I is equal to V by R according to Ohm's law. So in the energy storage, energy is dissipated as heat. So next, inductor. So inductor, resistor change in the current initially, it behaves like a short circuit once steady state is reached. So energy stored in a magnetic field. Capacitor, so initially acts as a short circuit but behaves like an open circuit once fully charged. So energy stored in an electric field. Thank you.